So today I'm going to show you on how to convert a mixed number to an improper fraction like this by creating a model. So this is my model here. I have one whole amount, this is my whole number, one whole amount, and 2/3 of another one. So I shaded one whole and 2 out of 3. And I just added the label so you can see this is one whole rectangle and 2/3 of a rectangle. So again, this is step 1, create your model. Step 2, you're going to split. So what I mean by that is you're going to just do the same thing again, so create the same model. Now, if you notice here, we have 2/3 of a rectangle shaded here. All you're going to do is, since this is split into thirds, you're going to split this whole rectangle into thirds as well. And now we have our improper fraction. And here you can see that we have 3 out of 3 shaded, 3 out of 3 slices shaded here. And here I have 2 out of 3 slices shaded. And now the solution is simply saying, okay, 1 and 2/3, which is what I started with, is equivalent to how many thirds altogether. So if you were to count all the thirds, 1, 2, 3, 4, 5, you can see 1 and 2/3 is the same thing as 5/3. And one thing to point out is, remember, 5/3 is the same thing as saying 5 of these thirds. So right, I have 1/3, 2/3, 3/3, 4/3, 5/3. So 5 of these is the same as saying 5/3. In example 2, I'm going to show you how 3 halves is the same thing as 7 halves. So you can see step 1 for my model, I have 1, 2, 3 whole rectangles, and then a half a rectangle. That's my 3.5 represented there. So 3.5, 1, 2, 3.5. And then notice in my second step, all I'm doing is just copying the same exact thing, except now I want to see, okay, how many halves are here? So I already have my 1/2 here. I just got to split these into halves like this. So I cut them all in half. And my solution is simply just counting how many halves do I have all together now. And you can see here I have 2 halves here, another 2 halves, another 2 halves, and then 1/2 extra. So what that lets me see is that 3 and 1/2 is the same thing as 1, 2, 3, 4, 5, 6, 7 halves. So 3.5 is the same thing as 7 halves. And don't forget that 7 halves is the same thing as just saying 7 of these halves. This is 1/2, right? These are each worth 1/2, and I have 7 of those that are filled in. And now in the next example, I'm going to show you how to go from an improper fraction like this to a mixed number like this. So your first step is always going to be to create your model for 5/3. And when you look at your denominator 3, that lets you know that you're going to draw a rectangle, you're going to split it into thirds. And then you're going to keep filling in the rectangles until you have 5/3 complete. And don't forget, 5/3 means you have 5 of these thirds. So you can see here, if I shade in these 3, I have 3 out of 3 shaded in. I need a total of 5/3, which means I'm going to split this up over here. And I need to shade in 2 more so I can have a total of 5/3. So you can see here I have 3/3 and another 2/3. So altogether, I have 5 of these thirds filled in. Because don't forget, this is 1/3. Each of these is worth 1/3. And since I have 5 of them, I have a total of 5/3. And when you're converting from an improper to a mixed number, all we're trying to really do is figure out how many whole amounts are in there. And you can see here I have one whole rectangle completely shaded in. So as you can see here, I have one whole rectangle. So when I say merge, we're just saying that 3 out of 3 is the same thing as just one whole rectangle. And I don't have a whole rectangle filled in here. I only have 2/3. So that's going to stay the same. So when we're going from improper to a mixed number, again, we're just trying to figure out how many whole rectangles are actually shaded in. And we can see here clearly that there's one whole rectangle shaded in. And then that leads me to the solution of 5/3 is the same thing as 1 and 2/3. And then for this next example, we're going to do the same thing. We're going to create a model for 7 halves here. And since my denominator is 2, I know I'm going to draw rectangles and I'm going to cut them in halves. So cut them into 2 parts each. And my numerator, which is 7, is letting me know that I'm going to fill in 7 of those halves. So again, 7 halves is the same thing as 7 of these halves. These are identical statements. They just look different. 7 halves is the same as that, which means I need 7 of these shaded in. So now you can see here I have 1, 2, 3, 4, 5, 6, 7 of those halves shaded in. And then you can see here that I have 2 out of 2 shaded, another 2 out of 2, another 2 out of 2 shaded, and 1 out of 2 shaded. So again, this is a total of 7 halves altogether. And then the question, when you're going from an improper to a mixed, again, they want to know how many whole rectangles are actually shaded in. So I can clearly see that there's 3 whole rectangles shaded in. And you can see that here from my labels, where I have 3 whole rectangles shaded in. And I labeled it as 1, 1, and 1. And then I have another half shaded in over here. It's not a whole rectangle, so we're just left with 3 whole and 1 extra half left over. So again, 7 halves. We're just trying to figure out how many of these actual rectangles are filled in all the way. And there's a total of 3. And then that brings me to my solution, which says that 7 halves is the same thing as 3.5 rectangles.